This week we are getting down to some of the meat and potatoes of algebra. So being able to solve a quadratic equation. So we spent the last week working on factoring and how to factor a quadratic so that we could use those skills today to actually solve a quadratic. So when you started working with variables in your equations, you solved linear equations. So variables that were to the first power. And you solved those by undoing your order of operations. So in the end, your goal is to get the variable all by itself, undo addition, subtraction, then undo multiplication, division, then undo your exponents, then undo your grouping symbols, and repeat if necessary. In the end, you came up with the variable was equal to some number, and then you could take that number, plug it back in for the variable, simplify it, and then you should get a true statement to when you do your check. So we're going to take those ideas and apply them to quadratics. So you can have a quadratic function, meaning you have an x and an f of x or a y. So you have a place to plug numbers in and a place to get numbers out. If you select enough x's, plug them in, and get their y values, you'll get a bunch of ordered pairs, which then you could graph and end up creating your parabola, or your U-shaped quadratic graph. However, if we take the y out and replace it with a number, let's say 0, now we've created a quadratic equation. So we only have one variable, x, and our equation is set equal to a 0. In this case, we have the ability to solve for x and figure out when y is 0, what is x. So some ways we've worked on solving quadratics in the past. Back in chapter 7, we worked on solving by graphing. So the parabola or the U-shaped graph, that would be your quadratic. So we're working with quadratics in standard form. So ax squared plus bx plus c. And then whatever number it was set equal to, that would have been your horizontal line. Where the two graphs cross each other, those x values are your answers. So if your parabola and your horizontal line cross twice, you have two solutions. If your parabola and your horizontal line only cross once, then you have one solution. There's only one number for x that works. And then, of course, if your parabola and your horizontal line never cross, then you have no solution. So when we are solving quadratics, we're either going to get two answers, one answer, or no answer. One of the things you liked about graphing is that you could actually see your answers. You could physically see where the lines are crossing. However, it was problematic to us when our answers were decimals or fractions because they were really hard to read. Some other ways that we've solved in the past. By undoing your order of operations. So if I had something like x squared equals 9, well, only thing with x is squaring it, so I could undo that by taking the square root of both sides. And the square root of 9 is positive or negative 3, so I end up with two answers. So if I plugged in positive 3 and squared it, I'd get 9. If I plugged in negative 3 and squared it, I'd get 9. So both numbers work. Well, what if I had something more like 3x squared minus 3 equals 0? I can still solve this by undoing the order of operations. I can move the negative 3 across the equal sign, so I can undo subtracting 3 by adding 3. Now I'm left with 3x squared equals 3. So after I undo addition, subtraction, then I undo multiplication, division, so I could divide both sides by 3 and end up with x squared is 1. Now I take the square root. The square root of 1 is positive 1 and negative 1. I could still plug that back in for x as positive 1, make sure it works. I could plug it in as negative 1, make sure it works. So both of these problems you could solve by undoing the order of operations. Well, what if I have something like two x squared plus x minus 3 equals 0? When I go to solve this by undoing my order of operations, most of you are saying, okay, let's move the 3. So undo your addition and subtraction. So I move the 3 to the other side. 2x squared plus x equals 3. Well, I can't add x squared and x together, so I'm stuck. But maybe I could get rid of the coefficient of 2? So if I divide this entire side by 2 and I divide this side by 2, well, now I get x squared plus x over 2 is 3 over 2. But I still can't add them together, and I can't take the square root of this because I don't know how to handle addition under a square root. So we're kind of stuck. So something we can get from this, if I do not have the b value, so this is just ax squared equals a number, and this one is ax squared minus c is some number. If I don't have a b value, I can solve it by undoing the order of operations. But when I have a b, ax squared plus bx plus c, I'm stuck and I cannot solve this by just undoing the order of operations. So I have to come up with a different plan in order to do that.